The Sweetley's test was done okay. I think a lot of you are actually getting the hang of it. The important thing of this test was it's kind of like the song by Meghan Trainor. It's all about the bass. So I gave you a list of bases to have a look at, and most of these you should have actually recognized. There are one or two little tricks in here, and just have a look at that. So we have, this is LDA over here. We've got potassium hydroxide, sodium ethoxide, butyl lithium. This one is probably one that you haven't seen before, but it's effectively the same as LDA over there. Just there's only silicon groups on there, but it's effectively a nitrogen which is a negatively charged because it's connected to the lithium. This one over here is lithium HMDS, hexamethyl disilazide. You can go and look that up. This one was maybe a bit of an obscure thing that I just threw in here. We wouldn't normally use it as a base. It's just a primary amine that's sterically bulky. But this is triethylamine, very good base, and then sodium hydride, which is a good base as well. All right, so the electrophiles should have been very easy to spot out of all of the reactions, and so we can put those in very quickly, just recognizing where the different disconnections have occurred. So right, so each of those should have been fairly easy to get to, and most of you got those correct. The bases, of course, require a little bit more attention, particularly because I said you could only use one of the bases once. Starting with the bottom one over here, when we're making TMS silyl ethers, triethylamine is the most common base, and we'd never use any of the other ones that are present over there. It's highly unlikely, and so yeah, triethylamine was the correct answer there. Over here, because we are alkylating at this position over here, which is in a beta dicarbonyl position, we've got a number of options. The sterically bulky bases are not a good idea. And we'll come to that a bit later when we deal with kinetic and thermodynamic stability, but they're not really a good idea at all with with this reaction. But sodium ethoxide matches the ester, so that would be a good one and would be my personal choice. But you could have also used sodium hydride to have deprotonated as well. I would have given you marks for that as well. So yeah, so just the sodium ethoxide would have been good over there. And these two over here, both of them we're alkylating just standard carbonyl compounds. And we need a strong, in order to do this alkylation, we need to form this enolate in high yields in both cases. And we need a strong base for that. So we use either LDA or the LHMDS. And it doesn't matter which way around we choose that, but those are the ones that we have to use. So really this was the only one that might have been tricked you. You would have been maybe stuck to which one you would have used there. Then we come to the mechanism, and that is a fairly trivial mechanism for the formation of an imine. So let me just quickly run through that with you. And there we go. That would have given you 2 marks for the formation of the imine. All right, good.